Hi, I'm Peter Hopkinson, co-director of the Circular Economy Hub for the NICER programme with Fiona Charnley. Fiona can't be here, I don't think. She may drop in later. But this is the probably the final event of the NICER programme, certainly for the CE Hub. And what we wanted to do was wrap up and conclude the work that we'd been doing on data and the Data Observatory, both within the Circular Economy Hub and across the NICER 5 centres. So we've got three speakers. We've got Lindsay Blake from DEFRA. Allow Lindsay to say a bit about her background. Then we switch over to Oliver and Marcus, who are really the architects and the real sort of creators of what the main feature today, which is the Data Observatory, what it is, how it works, and what it does, and how it might work in the future. So great, thanks for coming in and giving up a lunchtime or an hour of your time. Hope it's of interest to you. I'll stay off camera and microphone unless there's a problem, and then I'll come in at the end and sort of steer the Q&A and discussion. So Lindsay is going to kick off. Oliver, you're going to control the slides, and you'll feed in at the appropriate point after each other. Okay. Ready to go, Lindsay?
Yes. Sorry, I
Great.
was having a couple of problems coming off mute there, so my computer's
Yeah.
not playing ball. So if anything happens, please don't worry about me. It just means that my computer's not playing. So thanks very much for inviting me to speak with you today about my perspectives on the Data Observatory. So my name's Lindsay Blake, and I'm the lead scientist for the Circular Economy Directorate in DEFRA. I have a background in climate change, circular economy and waste, which are very interconnected in many ways. And I've worked across lots of different disciplines within academia and industry. So that's prepared me quite well to take on my current role, where I work at the science policy interface. So I'm not a policymaker, I'm a scientist. I lead the trajectory travel. Sorry, it's going to take me a while here, Oliver, on the first one. I've got a little bit more. I'll ask. Thank you ever so much. So I lead the trajectory travel for science and R&D within our directorate within DEFRA and feed into the wider scientific priorities of the department. So my team collaborate quite closely with evidence and analysis and policy teams to embed scientific thinking and evidence into policy making, which is quite important, and also make sure that science is represented at each point in the policy cycle. So we also build and maintain key relationships externally, which is why became involved in the NICER programme in the last couple of years. So I've been kind of sitting on the advisory group and programme board, and we have been working with Peter and the wider team in terms of developing parts of the Data Observatory for uses suitable for policymaking in DEFRA. So one of my aim here in this talk is just to show you a little bit more about our kind of thinking, a little bit background on circular economy from a DEFRA perspective at the moment. Is it okay to move on to the next slide, Oliver? Thank you. Okay, so none of this should be a surprise to any of us here. So we're all quite aware that the UK economy is highly linear and based on a take, make, grow model, which presents kind of, I would say, extreme economic, environmental and social risks, and that this linear system presents kind of a major loss of value from the system and has consequences for the future and current, which may be exacerbated with continuation of this system. So effectively, it's unsustainable in the long term. So moving to a circular economy may present significant benefits. So these are the benefits that, or some of the benefits, so economic growth and green jobs, using our resources more efficiently and productively, and also addressing environmental impacts and things like climate change through potentially net zero. Is it okay to go on to the next one here? Okay, so yeah, this just says a little bit more about kind of these benefits. So I'll just give you a second to have a look at them and see what the perspective is here rather than reading them out to you. But things that I'd like to highlight is kind of in boosting economic growth, there's also a kind of mechanism of supporting innovation and protecting our environment. The conscious thinking of transforming the system may allow us to address kind of complex and nuanced problems within the environment and sustainability. And also will kind of reduce our raw material dependence. So at its simplest base, this means that circularity reduces our reliance on raw material imports, and adds to resource security. Okay, are we okay to move on now, Oliver? Yeah. So, at the moment, delivering the circular economy transition is ambitious. It is a key contributor to the government's growth mission. And also, we're beginning this journey at present by developing a circular economy strategy, which will set out kind of the key vision, enablers, roadmaps for the trajectory of travel, and also a mechanism of a collaborative co-creation and working. So what I'd like to say is that I'm sure this all kind of sounds really positive from those people who've worked on the NICER programme in the last 4 or 5 years. And certainly for me, as someone who's worked on circular economy and waste for many years, it also is quite an exciting place to be. Can I have the next slide, please, Oliver? Thank you. Okay, so in addressing where we need to go, there's also kind of thinking about unlocking potential barriers. And there are going to be multiple barriers to unlock. So these are some initial ones, noting that more specific ones will become apparent in time. And obviously this is not an exhaustive list, but one of those barriers is data. And that can be in terms of data scarcity or siloed data use. And this is where I think the Data Observatory holds real potential to support the development of circular economy. Is it okay to move on to the next one, if that's all right? So essentially, I love something that Marcus quite often says when I've heard him saying, I won't quote him directly, but that we actually live in a really data-rich environment. And actually, it's our approach to data that potentially is limiting us. So essentially, a circular transition requires a system-wide change. Decision-making within that requires complex insights across a full system, and our current approach to data and collection, although fantastic in many ways, we have lots of publicly available data that is rigorous, well-formed, and also is collected regularly and published regularly. And we also do a lot of R&D, which again provides policy questions, but bringing that together is where you offer kind of that value for full system thinking. And sometimes we're missing those insights, and that the Data Observatory provides that solution. Is it okay to go on to the next one, if that's all right? So hopefully I'm not taking up too much of your time. So the Data Observatory is not new. It's building on the exceptional work of the hub and centres that fed in over the years and through the NICER programme. But at the moment, I'm highlighting a specific collaboration between the University of Exeter and DEFRA, where we're building on that work to take specific aspects forward with Peter and the team, which the team will talk about. So this includes commissioned works, which has been enhanced by the allocation of DEFRA fellows as well, and supplemented with our own science and economics dedicated time. And wider engagement from our policy and analysis colleagues, which have allowed us to shape something that can be used by policymakers. It also has links to the wider UKICE SRM as well, which is the first UN-backed Circular Economy Centre. And I just want to highlight one thing at the end, if that's okay, which is the work of the 2 fellows. Is it okay just to go to the last slide? It's okay. So I think actually I saw that Matt's on the call here, but Matt and Lionel have been working alongside our colleagues in the University of Exeter to supplement and pull in some work. And they actually presented this last week to the wider colleagues in DEFRA, who gave overwhelmingly excellent feedback to them and were in awe of the work. So I just want to say that this is a really valuable piece of work, and I'm really looking forward to what Marcus and Oliver are going to speak about next. And I hope I've not given anything away, because I tried not to.
Thank you, Lindsay, so much for your introduction and putting this into context. Oliver and I will speak now about the Data Observatory and how it's made up, sort of very quickly reflecting on the policy challenges that this could or is aiming to address, how it's being designed, and we show some case examples that also stem from the collaboration across the CE Hub activity work. There's Medcotech in there, TCC and the Minerals Center, which have contributed largely to some of the data that you're going to see as we move on. So if you go to the next page, And then the next one, sort of, we have a look at the policy requirements. And as Lindsay has already mentioned, circular economy is really important for many reasons. It's also a very intuitive concept, so it's very easy to understand at layman's term. But if you then dig into this on the next page, you see that there are a whole lot of questions that very quickly talk to it, which require some sort of data or some sort of representation to address them, specifically for coming up with the right recommendations and implementation. And this is compounded by the effect that we talk about material things. And on the next page, we give you a very quick sort of overview. There are many sort of strategy objectives on being carbon neutral, net zero. Almost any department has sort of its own strategy and vision. And it boils down to really managing the stock of stuff that we have around very differently, from solar panels to wind turbines, etc. And already this are potentially 100,000 of different product types. And the circularity very much hinges on the very specificities of these products. If you then break those up, the bill of materials, into components, this just explodes. Yeah? Sort of, you have multiple options to put an electric vehicle, different type of motors. And below this, then you have very few elements which form sort of the secret sauce of forming these component products. Now, what we have learned is that it's very important to differentiate between the material, the component and product layer to address the right resolution. For instance, recycling you can do at the material layer, refurbishment and repair at component and product layers. So it's very, very important to understand the right order of reference for the circular economy implementation. Now, if you add another dimension to it, it's on the next page, the value chain. So as Lindsay already said, it's a chain of activities coming from mining ores to producing components, putting them into vehicles. Here in the case example of electric vehicle motors using permanent magnets. The cost of usage, and then thereafter you have a decommissioning process, which hinges on really taking this in different forms apart. While the inflow is very well understood, at least by some players in the industry, the reverse side is typically not so well understood. And therefore, we do see very little reuse and refurbishment, recycling of these very precious material. And this is where data resolution becomes really critical. Because if you want to take this system and make it more circular, as in collaboration with the Med4Tech Center on the next page, you ask the question, why is it not happening by itself if it's so logical and so positive? Because there are so many implementation barriers. And it's very important to understand which of these barriers would you need to address from a technical solution, from a social engagement solution, from a business model solution, and therefore you do require data. Once you have the data available, you can, on the next page, prioritize different type of interventions. And they can be in the design, they can be enablers, they can be in the process capabilities, but they always typically only change fractions of the value chain. And in order to understand the full system, it's very important to understand how this ensemble of activities affects the overall system. Because if you would know that on the next page, you basically can monitor the output. You can see how are materials, components shifting back onto reverse options, offsetting the need for primary material intake. You can see what it does to resource productivity. Lindsay mentioned also jobs and emissions involved, also the secondaries. But you also can measure the progress of the underlying programs that do require resources, that do require time to be executed, that do require potentially a lot of policy to make it more incentivized. So this is the reason why we think a data observatory and a data approach to informing circular decision is very important. Now let's have a little bit a look at how this has been designed in more detail and what we think are the potential benefits for this. If you go to the next, it's an agnostic model. So what we try to do, and that's where we worked with the different centers like TCC and the minerals, is to come up with a representation of circular economy value chains independent of the type of product or material, with the intention that this allows to learn together faster than you can do by only doing very specific M&FA. It allows you to create data collection and baselines which you can reuse for other applications, and it helps to inform different type of policy dimensions. So in order to do this, we have created architecture on the next page, which basically has 3 layers. It starts with the top layer. Sort of if you wanted to see how the different systems interact, it's very important to understand where is the current value leakage in the value chain. What are the specific pain points that I just showed you for the Medford example? What are the externalities? What happens at portfolio play? And in order to evaluate this, we need a model that allows you to compare the linear with the more circular configuration, and then also test it for different assumptions. What happens if you would prolong the use of a vehicle by X%? What happened if you could refurbish 20%? Because it does have immediate impact on the metabolism of the materials and components and products going through the system. So in order to do this, we typically see 3 core models. So the first one is the bill of material model, which allows you to disaggregate a product into components, as I showed earlier. It's very important to have a sense around the reverse option, because many of those have not been developed at scale yet. So it's important to actually describe them at activity-based level to come up with the right resolution. And given that we're talking about physical stuff, it's important to have also a geospatial model. And Oliver will show you some of the analysis that we have built into this. Now, in order to feed this model, it's important to have different data sources. And that's where we actually believe there's a lot of data available, but you need to pool them into a consistent model to enable reuse. That's what we try to do with this multi-layer architecture, which you also will see in the implemented version that Oliver is going to show. Now, on the next page, we come back to this overview, and you can start clicking, Oliver. It's an animated chart. So we need to have the secondary materials, we have the primary materials, but on top of this, you can enforce different type of legislation or levers. So if you talk about external producer responsibility, it's very frequently a component or a product play. If you talk about bans, it's very much around making sure that critical materials or not wanted materials enter the system. It's very much around setting targets. You can set up directives on design and packaging, etc. So there are very different levels of incentives, and this is coming not from technology metal, this comes from the joint work that Lindsay mentioned on plastic. So it's packaging. So it's important to use a very standardized representation for multiple different type of products. Now, with this approach, we think this is actually delivering or has the potential to deliver a number of very relevant features. We think it's trusted and scalable. It can be applied across different questions from governmental services. We think it's efficient because if you start to pool data, you can reuse it for multiple requests, not only for one. It can be applied to almost any type of material and product and sectors by leveraging the same taxonomy for the different activities, but by populating with specific data. And we think that's very important to explore and test the impacts across the full system, because that's where you also can account for unintended consequences. So we think that this type of systems-wide modeling is really essential to inform and track the progression of circular economy initiatives. Next page, please. Let's look at 2 very specific cases. The first one is coming from permanent magnets. This was again done together with the Medford Tech. Sorry, I need to take a little bit of water. Together work with Medford Tech, also where BGS was heavily involved in building a version of a national virtual observatory. If you go on. So we asked the question, what would it take to decarbonize UK economy? And thanks to National Grid, there are some very sort of well-formed targets which show how you could shift the energy mix of the UK. Now, shifting the energy mix of the UK does require to shift the type of assets that you have in the UK economy to achieve, to generate and to use these type of energies. Both in the generation, you very much depend on a significant increase in wind turbines and a significant increase in electric vehicles. And therefore, we started to map out, for instance, here, the value chain, the baseline of what is currently present in the electric vehicle value chain. And you do see that there is a massive amount of manufacturing at the magnets level, but it's a byproduct which is then also being exported and goes to other applications. But we largely start to build up the stock. Now, whereas permanent magnets are of great interest, and you follow the recent political discussion, also recognized by some global leaders, it's for the reason it is a secret dust that makes decarbonization possible. But against almost all of the materials, we know that we are sort of stripping against the known type of demand. So it's really important to think through how to reduce this primary demand by potentially evaluating reverse circular opportunities to hold the stock that you already have in place in use for longer in a local economy. And that was done on the next page. We looked into the wind turbines, and it's a very well data-rich environment because you need a commission license to operate. So you know already now where these wind turbines are, and you also know in the future where they're likely to be because you need to get them certified and licensed. And if you then only look into the stock, which has been built up until 2020, there are a significant amount of tons already in place, of which the very first ones, after sort of a 20-25-year timeline, will become available in the next couple of years already. It's small volumes, but as you see at the ramp up at larger volumes fairly quickly. On the next page, please. Now, if you take these projections until 2050, and there was recent work by BGS on foresight studies to look into these type of critical decarbonization enablers, there is a massive amount of stock that will need to be accumulated. But if you look into the multi-decade horizon, some of this will become available because it needs to be replaced, reaching its end of technical life. And if you only take what is becoming available and multiply it with today's prices, it's over 7 billion worth in pounds, what the turnover of assets will be. And it's obviously not taking into consideration yet the cost of bringing it back, but it's sort of the raw potential at continuous prices. If you look into the price trends on some of the materials and the significant demand-supply imbalance, that could likely increase significantly. Now, what we've done is put this into the model and played around with different levers. Sort of, can you actually extend the product life? Can you potentially think about bringing this back for different type of versions? And on the next page, you do see that you start to decrease the ramp up in primary demand by introducing circularity into the mix. And this is exactly where policy is very important to provide oversight and foresight, but also to the right leveraging of incentives that private sector can take benefit of these opportunities. So there's a significant opportunity to recapture some of this value locally. And on the last page, we have been putting this into a model which allows us to simulate. And Oliver is going to show this a bit more. Depending on what type of scenario you're using, what type of lever you are implementing, you can see directly the different types of projections. And why this, we call this frequently the 16th century map, because it's working a lot with assumptions. It gives you an order of magnitude of the potential that different circular economy interventions can deliver. And this is very important to inform both public policy making, but also private sector business case opportunity spotting. So this was a quick overview on what we wanted to do with the NVO, how it has been tested in some real cases. And we have done this now for rare earths in some detail. What we also have done, and this is now very quick snapshots, we tested this for other material streams. We looked into plastics packaging for the UK, and you see that we have different elements. We have taken this for glass packaging. This goes back to the two fellows that Lindsay mentioned earlier, leveraging also some of the data that has been put together by UKRI, CE Hub, and the associated centers. And we also have taken this for construction minerals in glazing from the work that was done in the Minerals Center. And we show this at the textile centers as well. We just wanted to show this agnostic approach allows us to represent data in very similar fashions, allowing sort of to jointly learn from what works for what type of products. Thanks so much. And Oliver will now show you both the live version and also a bit more sort of the technicalities behind this.
Hi, everyone. Many thanks, Marcus. So now is an opportunity to take a short guided tour of the Data Observatory site itself. And what we have sought to build on top of a growing repository of data on materials in the UK economy, alongside linked economic and impact dimensions, is a user-friendly interface intended to support across the policy cycle, horizon scanning and prioritization, monitoring and evaluation. As Marcus has said, the data sitting behind this interface has come from a range of sources, including official government data, research across the NICER program, and developed through the 2024-25 DEFRA Fellowship Program too. As you will see from the left-hand side in the navigation bar, the main website is structured around a set of pages, grouped into those showing data on specific materials and products, a geospatial viewer, wider data of relevance collated into a data pool, and then pages covering metadata aspects such as indicator definitions and data sources. On each page and on the baseline side, you'll see this consists of indicators and charts showing key information, including in particular a Sankey as a core component for representing material flows. This can be interacted with, both the KPIs and the Sankey, through a set of filters. And at the level of individual observations, the quality of the data is presented in an attempt to capture the quality of the data, while the Sankey is clickable and can be made clickable so that you can zoom in to see specific areas of information in greater detail. In addition to these core components, we capture time series and other relevant data types, and these can be browsed below. And this includes data sets that have inputted to the material flow analysis, such as presented above. In addition to economic data, such as on GVA, business numbers and employment in related sectors. In this case, as one example, the manufacturing of plastic packaging in the United Kingdom. And then also information down to the level of specific facilities, such as those who are accredited reprocessors of plastic packaging in the UK. In addition, we try to capture information such as relating to the policy and process on the likes of the plastic packaging tax and other policy relevant data, and then inputs such as prices as well. Alongside the baseline assessment and monitoring view, we also have a scenario view. Here, the user can explore forward-looking scenarios, filterable very much in the same way as the baseline. And in addition, with policies or more general scenarios applied to them. In the case of the policies, these link to a repository of assumptions on different policies. And once scenarios are ran by the user, these can be downloaded and exported for further use. We've developed this part of the site in a way that diverse models can really be integrated with some ease. And therefore, whilst this is capturing one specific model, we also have additional on the site too. Alongside these product and material specific sites, or pages rather, we've incorporated a viewer for geospatial data, which can take the form of points data or 2 polygons data, And as one example of the data sets integrated, what you see in front of you is the registry of reprocessors from the National Packaging Waste Database. You can see over time the changes in these. And you can filter the data in a variety of different ways. And this is one example of a data set, but we have some additional ones captured, such as on the different permitted waste sites across England in that specific case. As well as those pages specific to products and materials and the geospatial components, in this wider data pool, where you can explore by different data sources, searching by term and publisher, we house data that hasn't necessarily been incorporated into a material or product profile yet, but which may still be of interest to users. And what you can see is we're pulling in a range of different data sources. Here, single-use carrier bags, but many, many others. DEFRA data, EA data directly. And we're bringing these together so as to provide a time series view, which isn't always provided for in the publications themselves. Often they're published as annual snapshots and covering a whole variety of information. And these data can be downloaded by a user, and the majority of the data also links back to a data extraction script, which is an important part that we'll cover in a moment. Behind the web interface for viewing and interacting with the data just presented, there are a number of software components helping the site to function and linking data contributors to data users. In particular, a custom content management system. This has been developed to allow site contributors to access data for building their case, such as from the UK Trade API or Comtrade. Design dashboard component through no-code population of reusable components, and also interact with the database where our data is stored. In addition here, external data contributors can have a profile created for them, and which will allow them to submit data that is reviewed by us before being integrated into the site. As explained with the scenario components, sat behind this is a server, which we use as a means to run dynamic models for presenting custom scenarios. And in addition, these open source components, we have a public repository of scripts written in R, Python primarily, and models, so that people can really trace back to the sources, exactly what we've done, the calculation steps that we've undertaken, and also use those scripts themselves to generate value. The site presents data both as is from sources, as well as data subject to further integration and manipulation to estimate particular data points, such as in the example to the top left, in an attempt to estimate flows of plastic packaging in the United Kingdom. Data extraction, cleaning, and wider transformation to populate the charts and components is performed wherever possible using scripts written in open source programming languages. And a scripted approach has been adopted for a few reasons. Firstly, for verifiability and replicability. This is aligned very much to the reproducible analytical pipelines idea, which is encouraged in the UK government and wider. Updatability. So of course, we want to make sure that the data presented on the site is as current as possible. And this allows, in combination with a scheduler, for us to run these scripts and automatically update the data on the site. And in addition, easy scalability to other materials or products of interest. So whilst, for example, we are populating a specific case around plastic packaging in the top left, every time we go to a data source, we're looking to extract the entirety of the data where we can, or build up pipelines, such as to connect to APIs for extracting data for additional materials and products in the future. In the process of adding data to the site, Sources are classified against criteria as part of inventorying and to help inform users around data provenance. The metadata catalog also captures information that inputs to a quality scoring approach, such as shown with the Sankey earlier, covering information such as the materials, applications, and processes covered by a source, spatial coverage, timeliness dimensions, and quality aspects such as documentation and QA. Of a whole variety of sources long listed, and we undertook an extensive review of public data in the UK a few years back and have built off of this. Whenever we are shortlisting data inputs, we are doing so on the basis such as completeness, detail, and accuracy in an attempt to use the best available data wherever we can. And throughout the site, we have sought to adopt a transparent approach to model building, both on the baseline side and forward-looking. And this can allow for the assumptions and new data to be incorporated and the model overall refined. So we're not saying that this is the be-all and end-all, but the idea is that people can continue to build on the model and improve things as we go along. As shown on screen here, and in the Sankey earlier, we have in place an approach to calculate confidence scores in different observations on the site, accounting for geographical, temporal, technological, completeness, and reliability information as captured in the metadata catalog. And these criteria are described further on the site, alongside key information such as indicator definitions. Many thanks. Okay, that's me. Thank you.
You done, Oliver?
Yes.
Okay.
Over to you.
Okay, great. Thanks, Lindsay, Marcus, Oliver. So we've got about 15, just over 15 minutes for anybody who wants to come in and ask a question or make a comment or anything you so wish, or we'll go for an early lunch. Does anybody want to come in? And I can't see any questions in the chat box. I don't know whether people have been overwhelmed by the amount of detail, but Alfie.
Hello, can you hear me? I'm going to move you down here so I can look you in the eye.
Yes, yeah, I hear you.
Thanks, everybody. Thanks so much. Really, really interesting. And I guess you guys clearly have a really good understanding of how some of these things, especially I think your scenario trajectories, we're thinking in terms of the value of material leakage or the value of materials disposed of in the sort of high recovery, extending use life scenarios. It's incredibly helpful for deciding how perhaps interventionalist policy approach you can take. Do you go from a position of banning products outright if they're incredibly low value, very interventionist? If you're going to be able to validate that position to market, oh boy, there better be enough evidence to allow you to do that. So I guess maybe my loaded question based on that is, at the moment you've looked through the lens based on materials or the sort of engineering of a particular product. Me and Peter know each other. I work in the medical devices sphere with Department of Health and Social Care. How difficult would it be to sort of run a similar thing, or to put through this dashboard something at a sort of sectoral level? Let's say we picked up, a product category as wide as diabetes care, or even like wearable diabetes equipment or something like this. Is it even plausible to do something where these devices are highly composite? It's not quite the same as glass or textiles. This might include 20 to 25 different sort of ComStat type commodities in manufacture. How would that work?
Marcus.
No, so we have done some work on medical equipment as well. Sort of the trick is, if you have a wide spectrum of potential products, is to find sort of a representative one, because that allows you to focus the data collection, and it allows you sort of to get to the necessary level of detail. And very frequently, you would need to speak to people upstream or downstream of your position to understand what they can do. And then this is a bill of material. It's also important to break this out into the different components and material streams, because they carry very different technological solutions and different value, and also making there some smart choices to focus on what's in general possible allows you to fairly quickly get to a sense of what different material streams could be.
Marcus,
Designed from
Alfie, we're just getting a bit of background noise from. Yep, thanks. Sorry, Marcus.
No, so it's designed around from to start with the application layer and then break this into a signature product, which you then can disintegrate into multiple streams. And this was done, for instance, when we did this for electric vehicle, we have sort of shown the motor component, but you can do the very similar thing for aluminium and other material streams because they share a lot of the same data, but they share very different properties on the way on how you can bring this back. So it's important sort of to follow this bill of materials stream and make a choice on where you specifically see the opportunity. And we have done this also at regional level. So for different applications, for instance, in the Southwest, looking at a whole set of different signature applications, but from a regional point of view, because the type of collection incentives, the type of processing capabilities sometimes really depend on where you are physically on the map as well.
Extremely helpful. Thank you, Marcus.
Just to add to that, Alfie, Marcus mentioned in passing, I think, earlier on, there was a piece of work with Exeter and the British Geological Survey last year, which was looking at 7 decarbonisation technologies and wasn't quite the same model or the same analysis, but it was trying to get back to the bill of materials, and that was for heat pumps, it was for electrolyzers, it was for fuel cells, it was for small scale nuclear, solar, these complex bill of materials with medium to long term life cycles. So I think Marcus and Oliver mentioned about this being an agnostic methodology, which you can scale up, increase the scope and scale up to a wide portfolio of different types of materials and products. That's the whole philosophy behind it, so that you don't always have to go back to the start and you don't get competing models or frameworks. So if you can build consistency in at the start, you're always increasing the efficiency of your approach. And every case is different, but every case has a lot of similarity once you start to understand that there's a sort of a reasonably small, not small, but a relatively low number of data sets that you can go to, and you start to augment with other types of industry data to find the missing pieces that you can't get in the public data set. So a long answer. So the short answer is yes, you can.
No, yeah, really helpful. And I think the way that Marcus put it as well, it seems that certainly we're taking a bill of material view, maybe eventually you find, I'm going to call them the rate determining components in terms of the supply chain, where the majority of risk or where the majority of policy opportunity is. And yeah, no, from your system, it sounds like you're able to explore that early and then really get under the skin of the areas that, as I said, the other rate determining areas for your policy. So very interesting. Thank you.
And the other piece of the jigsaw that Oliver's explained is, as you know, when you go to something like NHS procurement data or medical devices in use, there is a universe of really complex fragmented data. It's there, but it's really complex. So using the types of approach and methodologies that Oliver's described gives you a chance of pulling that, extracting that data out in a form that enables it to be cleaned and used with some confidence, and then you apply the type of quality assurance that Oliver's described. So the general methodology applies in many different ways to different contexts. Good. Any other question from anybody? Anybody got any applications that they would like to test out or want to float past us, like Alfie's just done, where you sort of say, could it be used for this? Could it be used for that? If not, we can say a little bit about what might happen next. I think Lindsay's still on the call, and other people. Are you still there, Lindsay? Yeah, we could just have a 2 or 3 minutes to talk about what we think might happen next, and Lindsay might want to kick off from a government perspective, and then maybe Marcus, Oliver, and I can say something about what our thinking is. As we approach March the 31st, official end of NISA. So what happens on April the 1st? Ha ha. So Lindsay.
Yeah, I'm happy to kick off. So I guess this approach has been really useful, and I think what we've done in the last year, well, I'd say the last year, Peter, when we've been working together, show that it's applicable to kind of wider areas than had been looked at previously. You and the team and the fellows have done an excellent job of just being able to refine it for policy use, and also not just for policy use, for the kind of science or economic or statistical sort of interface of evidence within government as well. So I think it's something that we could potentially use to support us as we're kind of developing the activities with the Circular Economy Task Force and on the Circular Economy Strategy. So this is the type of the approach that'd be really valuable there. Looking at different sectors potentially.
Great. I mean, Marcus and Oliver, would you like to come in with your reflections? You've been at the heart of this for a long time. So, apart from the great pleasure of seeing this sort of being created and then being useful, how do you see things possibly developing? Where do you see the biggest developments in the next stage, whatever that is?
Yeah, I think from my side, it's also the time to say thank you. I think this wouldn't have been possible without the collaboration across the NISA program. As you've seen, there's a lot of data available. There's a lot of insights required specifically for processes which don't exist at scale yet, to get judgments on what is technically feasible, roughly at what costs, etc. So, and we think that the community that has been built around this, the data source that has been built around this, sort of is far richer than what we have been able to document so far. So I think one point will be to really think through that we find some way to document this and also extract the meta learning on what we have seen work and what is potentially a bit harder to achieve, to continue to inform the ongoing discussion on policy, but also business model evaluation. And I think that's where this has been so well enough road tested that onboarding further applications, I think, would be very natural step. So I think that would be the two main priorities going forward from my point of view. But again, sort of a big thank you to all of those who have contributed data, time, feedback, and reflections to make this develop so nicely over the last couple of years. Thank you.
Great. Lindsay.
Can I come back in? Because I just was thinking as well about other things that we've spoken about that I think are really useful, like extending the kind of wider social environmental metrics for the Data Observatory is really valuable. And for example, aligning with the net zero carbon accounting needs, something really useful and has wider applicability, but also that kind of policy scenario building within complex systems. And driving forward the work of the Data Observatory in that way, really useful in terms of looking at potential futures and trajectories of travel and what needs to be true for things to change. So, I mean, essentially, at the end of the day, you can't change what you can't measure. And this allows you to look at what you can measure over a full system, which is incredibly valuable. Sorry, Peter, I wasn't prepared for the question. Otherwise, I would have said that the first time.
That's all right. Luckily, we've got a little bit of time to allow and come back in again if another thought pops in your head, Lindsay. So, Oliver, any thoughts from you in anything that you've talked about or thought about?
I think a few. So, firstly, I could see there being a lot of potential for a deeper integration and linking of the different data sources we're extracting, whether at the sectoral level, so as to give a better picture of material flows, related to particular sectors, alongside environmental data, and even down to the facilities level, which is possible with some of the public data which is out there. I think in addition, an important part will be scaling, as of course you've got different methodologies. Some are more top down, some are more bottom up. I would associate this population so far with a bottom up, highly detailed approach. And what would be great to see is that scaling to additional applications, additional materials. And then I think finally, after multiple years of wrangling with different data sources and some of the difficulties that can come with, for example, extracting data which has been put into an infographic and then put into a PDF. I think what I would love to see going into the future is that some of the approaches that we've sought to adopt are things that could be adopted more widely as well. So there is a focus for our side on the FAIR principles, RAP principles, and I think it would be great to see some of those key data producers. I think it's done very well in the government, but I think in government adjacent organizations, it would be great to see that dissemination of data is improved, and we make it easier to be able to integrate this data, because that ultimately ends up being quite a big blocker to bring these different data sources together and answer questions on the circular economy. Yeah, that's it from me.
Okay, great. I saw a couple of questions, and I might just pick those up in a few final reflections. One is that we continually benchmark what else is happening out in the world, because what we're trying to avoid is duplication or replication. That'd be a complete waste of time. So that we're continually thinking, what is the added value of the work we're doing? So we've tended to be very UK focused because the nature of our funding, but we know that there are developments at UN level, international level. There are emerging international standards and guidance on the measurement and the metrics for the circular economy. So in terms of future proofing, we want to make sure that whatever we do remains aligned and we don't duplicate. So it's a two-way process. That we want to future proof. So the digital waste tracking, the question that's just come in, will it feed into this over time? That as that evolves and the waste tracker and other digital passports, that these things are thought about in advance so that they can harmonize and communicate with each other. We don't end up creating a set of non-interoperable sort of approaches to data, the I in the FAIR principle. I think ultimately, from my point of view, and Marcus knows, is that we're talking about the circular economy, which is a fast-moving field. 10 years ago, we weren't talking about it in the same way. And as Lindsay said, that our primary aim is to improve the evidence base for the circular economy and many of the claims that are made for the circular economy, of which there are many. Many of them are unproven or not substantiated by data or robust scientific evidence. So if there's one thing that we're trying to do, it's one, making sure the scientific evidence base for the circular economy is sound and builds confidence. And secondly, we want to make sure that we put the economy back into the circular economy. So there's plenty of circular out there, as you'll know. When you get into the economic dimensions, the economic modeling at different scales, particularly at the aggregate national, the data and the results start to become very, very sort of vague and difficult to test. So part of what we've been doing, which we haven't talked about today, is building some different models for that macroeconomic piece, which will interlink with the observatory, but that's for another presentation down the line. So can people explore the data observatory? We need to wait for DEFRA to quality assure some of the data from the most recent project that's in there, so that it doesn't. So if people do go in and download and maybe start to reference it, that DEFRA needs to ensure that they've been through a due process. So the answer is yes, but not quite yet. And obviously we would love people to go in and have a look and give feedback. The whole purpose of it is for it to be useful and helpful for people in their different areas, and what Oliver talked about as the role of contribution. as well as extraction. So a lot of what we've talked about today is extraction, with some contribution from the nicer centres. We want more contribution. So yeah, we'll do with that. And yes, we will share the recording, I think, Oliver, after the session. So Lindsay, do you want the final word?
I wasn't anticipating that, but thanks to you all for your talks and for your work and for your collaboration and for the NICER programme and what it's delivered. I think there's some fantastic work there that can be utilised by government and much wider.
And if today's piqued your interest, or you want to know more, you want to find a way to collaborate, engage, whatever, just drop us a line, and we'll come back to you as soon as possible. So, thanks everyone for giving up an hour of your time. Hopefully, it's been useful and productive. You've learned something, and NICER is almost over. So hopefully there will be many developments out of the NICER program, of which this is one, and we'll sort of hopefully sort of continue to engage and collaborate with those on the call who are interested in the next wave, whatever shape or form that takes. So have a great day wherever you are, and the rest of the day. So thank you very much. Goodbye from me, goodbye from them. See you soon. Bye.